Okay, good morning, class. Now I'm going to be discussing again this Mclaurin series as requested by one of your classmates. So in Mclaurin series, it's easy to remember in this formula. If you have the function of x, first you have the function at x approaches 0, and then you get the first derivative, that is if prime, and then you have x with the first degree, and then you have the value of x is equal to 0, and then and so on. One thing that you have to take note is that if you have your second derivative, it should be second degree and second factorial. And similarly, you also have three derivative. You have three degree, third degree, and then three factorials, and so on and so forth. In other words, if you have to the fourth derivative, you have x to the power of 4. You have fourth derivative as x approaches to 0, and then fourth factorial. Okay, so let's have an example. Okay, class, so in this example, you have here to determine the first four terms of the power series cosine x. So start by writing this function of x for cosine x. Okay. So as x approaches to 0, so what is cosine x or cosine 0? Cosine 0 is equal to 1. Okay, in the calculator, the cosine of 0 is 1. Now, get the first derivative. Okay. The derivative of cosine x is negative sine x. Okay, so as x approaches to 0, negative sine 0, sine 0 is 0, you have 0. Get the second derivative, that is derivative of sine is cosine x. So substitute as x approaches to 0, you have negative cosine 0 is negative 1. We try as much as to the higher derivative to show how would it look in the series of this function cosine x. So at the third derivative of cosine is negative sine, so this means you have positive sine x, and then get the value as x approaches to 0. So sine 0 is equal to 0. And the fourth derivative of sine x is cosine x. Again, do the same step. X approaches to 0, cosine of 0 is equal to 1. Then let's try more. Fifth derivative, this is negative sine x, and this is this is fifth derivative, negative sine of 0 is equal to 0. Maybe I could just try up to the sixth derivative. X, derivative of sine is cosine, so this is negative cosine x, and then you have on the sixth derivative as x approaches to 0, you have negative cosine of 0 is equal to negative 1. Now let us substitute in this formula. Okay, the function of x, okay, in the series for cosine x, this function as x approaches to 0, this one f0, you have 1, and then you have x, okay, f, or the first derivative, you have here 0, so this means this is 0, and then you have x squared 2 factorial. Second derivative is this one, negative 1, and then you have here the third we are on the 1, 2, 3, 4th term, and then 3 factorial. The third derivative we have here, this is 0. Okay, you can see, you have this is one is 0, this is also 0. We just only have two terms, so we need the first four terms, because this term and this one is equal to 0. So third degree, you have the fourth degree, fourth factorial. Of course, you have the fourth derivative is equal to 1. Okay, and then actually the fifth derivative is also 0, so we can just write it 0. This is fifth, and then you have x to the power of 6 factorial, and then you have the sixth derivative, which is equal to -1, and so on. Okay, so the first four terms, okay, you have here 1, you have here plus x squared, no, sorry, this one should be negative. Okay, wait, this one, okay, should be negative. Okay, this is -1, and then you have 2 factorial, and then you have here positive x to the power 4 factorial, and then you have here x to the power of 6 factorial. Take note that this is negative, so this one should be negative. Okay, so these are the first four terms for this power series for cosine x. Okay, next problem. You have here to find the first 5 terms for the expansion of the function. And the function is, you have here fx e to the power of 3x. Now let us substitute the value of x is equal to 0. This becomes 0, so meaning this is equal to 1. Now the first derivative, you have here e 3x, and then the derivative of 3x is 3. Okay, so substitute the value of x equal to 0. Of course, e0 or e0 times 3, this one is equal to 1, this becomes 3. Okay, second derivative, sorry, x, you have here 3e 3x times 3, so this becomes 9e to the power of 3x. Get the value of x equals to 0, so obviously this is 0, or 0 becomes 1, so this is equal to 9. Third derivative of this function, you have your 9e3x, and then you have 3, so this means you have 27e3x. Get the value of the third derivative. As x approaches to 0, this means you have 27, because this is equals to 1. See, is 0. Then you have the fourth derivative. You got here 27e3x, so you have 27 times 3. Okay, so you have here, okay, wait, 27 times 3 is 81. This is, it should be multiplied by 3, so this is 81e3x. Now let us substitute the value at fourth derivative. X approaches to 0, this means you have 81. Okay, let's just go back to this formula. So you have the function of x. Okay, as x approaches to 0, you have this value 1. Then you have x, the first derivative, you have 3. Then you have x squared 2 factorial. Second derivative is 9, and then x cube, third 3 factorials, third derivative is 27. Okay, and then you have next x to the power 4 factorial, and you have here 81. Okay, we can just rewrite this as 1 plus 3x You have here 9x squared 2 factorial. You have 27x cubed 3 factorials, and then you have 81x to the power 4 4 factorials. Okay. Okay, now let's talk about Taylor series. Okay, so in Taylor series, you have here this formula as x approaches to a. You have here, and then you have in the first derivative, you have if x approaches to a, and then x minus a, and then again the second derivative, x approaches to a, 2 factorial, and then x minus a to the power of 2, and so on. Now there is similarity with the formula. If you could remember the Mclaurin series, this one, Mclaurin series is coming from Taylor series, could be derived from there if we substitute a equals to 0, because when a is equal to 0, this comes your formula. This one comes a is equal to 0, and a will become 0. That becomes x only. And if you are going to do it for the entire series, you will come out with this formula, and this formula is actually a Mclaurin series. So one thing that you have to remember here again is in the series is with regards to the degree and the derivative. Okay, so here first derivative, first degree 1, and then 1 factorial. Here second derivative, you have second degree, and then you have second factorial, and so on. Okay, so let's try for our example. Okay, so let us try this example. You have here to obtain the Taylor series for this function, natural logarithm of x. So let us write as x approaches to 2, meaning a is equal to 2. You have here f x. Okay, you have here ln or natural logarithm of x, and then let us try to substitute the value when x approaches to 2. You have here, of course, this one. Get the first derivative. First derivative, we shall have just 1 over x. Okay. Okay. Substitute the value. Okay, equals to 2. You have here 1/2. We can also rewrite this one as x negative 1, so that it would be easy for us to get the second derivative. Second derivative, you have here negative 1, and then x minus 1, and minus 1 is negative 2. So you have here negative x minus 2, or negative 1 x squared, like that. Okay, so when you have the second derivative as x approaches to 2, you have negative 1 over 2 to the power of 2 is 4. Okay, let us continue to the third degree. This becomes negative 1 times negative 2. This is positive 3, of course positive 2 x. Negative 2 minus 1 is negative 3. Okay, so you have this is also equals to 2x cubed. Okay, so you have substituting the value of x equals to 2. Okay, so you have here 2, 8, right? 2 to the power of 3 is 8, and this is the same as 1 over 4. Fourth derivative, x, you shall have negative 6x negative 4, or you shall have negative 6x 4. Substituting the value of 2, you have here negative 6, 2 times 2, 4 times 8 times 2, 16. Okay, or you shall have negative divided by, let's say, 2, 3, and then 8. Okay, let us substitute the value. First function as x approaches to a, you have this one, natural logarithm of 2. Then just follow with this formula. F first derivative, you have 1/2, and then x minus a. X minus a is A is 2. Okay, and then next is we are here done with the first derivative. Second derivative, the second derivative we have here, this one. Okay, minus 1 over 4, minus 1 over 4 all over 2 factorial. Okay, and then x minus 2, this is 2, this is power 2 squared. And then you have next here is the third derivative. The third derivative is again this is 1/4, 1 over 4. This is 3 factorials, and then x minus 2, see, from 2 becomes 3. Okay, again, fourth derivative, you have negative 3 over 8, and this 3 factorials becomes 4 factorials, and you have x minus 2 power 4. Okay, so we can simplify. Okay, this is x minus 2 over 2 plus, you have here negative 1/4. This is 2. This one should be a negative. Okay, you have here x minus 2 squared, 4 times 2 factorial, this is 8. Okay, or yeah, yes, and then you have here, you can have here x minus 2, 3, and then you have here 4 times 3 factorials, and then this one should be negative 3 x minus 2 to the power 4, and then you have 8 times 4 factorials. Then you can simplify further this 3 factorials similarly with this one. Okay, but logically we already have this series. Okay, so I think that's all for the Mclaurin series and Taylor series. So if you have if you have doubts, if you have questions, just drop your question, your message in my inbox through Outlook. Thank you.